All right, so at this point, a good number of you guys did the pre-lab and you knocked it out. But if you did not do the pre-lab, you need to do that first, just to be clear. So I'm going to go over all the pre-lab questions real quick. Be 2 seconds, okay? So you do have this background info. That is where you would have heard about the whole electron that was jumping up to excited state, just like our little kid analogy, right? So he jumps up to excited state by absorbing energy, and when it falls back down to ground state, that's when we got to see the color, right? So that's all described right here in this background info. So you do have that still to fall back on. All right, so what you should have in your journal, written in your journal, not on the paper, okay, in your journal, is you should have your name, date, title, and then the purpose statement. The purpose was right here. So make sure you have that written in there. Okay, so once you have that, then you went to the pre-lab questions. Oh, now you guys can actually do your sketch of the setup, right? You guys got to see what the setup was, so feel free to draw yourself a little image of what that is. So maybe give yourself a little reminder that you should knock out number 2 today, which is, what was the setup? There was a Bunsen burner, there was a little lighter, and then you had a little Q-tip that you put into the flame, right? There was a beaker in there, okay? And then any of the safety rules that we had to follow. Okay, now down to your pre-lab questions. So double check your pre-lab if you already had yours done. Just double check with me that you have 4 definitions in there. You should have looked up ground state, excited state, absorption, and emission, or looked in the paragraph at the top. Okay, then you went to your data table and you knocked out number 2. So look at your data table, and what you did was you took care of those first 3 columns, right? So we used the example of barium. We looked on our periodic table and found that it was atomic number 56. It was found in the 6th row, 6th period, and then we looked in the 2nd column. So you had that done for all of your metals. Again, that's only the first thing listed. Okay, so those should be all filled in. Okay, so back to the pre-lab questions. Number 3. All right, so this is where I'm going to help. So number 3, it said, how does an electron move from ground state to excited state? So what did we just go over? How did the electron go from ground state up to excited state? It absorbed energy, exactly. So we have absorbs energy. And we specified that it was the heat, right? It was an infrared energy wave. Okay? So it absorbed energy to go from ground up to excited. And then the second part of this question says, when will you see the color? When it falls back to ground state. Good. So when will you see the color? Yes. When it falls down to ground state. Okay. Number 5. Number 4 said, is the energy directly related to wavelength or directly related to frequency? So I'm going to get the picture that's up on the board. I'm just going to draw it really. There you go. All right, that's what's up on the board. That's our electromagnetic spectrum. Remember, this is the radio end. This is your gamma end. So we know gamma end, we always relate it to the Hulk. And also radio is floating around. So if you don't know who the Hulk is, radio is floating around. So we know that that's not going to do much damage to us, right? But the Hulk, yeah, you turn in the Hulk. And that's a whole mutation thing. All right, so this end of the spectrum, we know Hulk is high energy. That frequency had to be very frequent. So high frequency, because it had to penetrate through a skin. And those little wavelengths, if you're measuring from crest to crest compared to what our radio waves were, those are super tiny. So very small wavelengths. Right? That's the whole idea here. Okay? So then you know that radio is going to be the opposite. We're going to have low energy, we're going to have low frequency, and very big wavelengths. Okay? So now looking at those arrows, which one is energy directly related to? Frequency or wavelength? Which one is it the same as? Frequency. Frequency. Okay? So it should be frequency. The fact that these two arrows are going the same direction. Okay? That's a big concept that you're going to need for one of the post-lab questions. So remember that. Okay? Energy is closer to frequency than it is its opposite of wavelength in terms of increasing and decreasing. All right, so that was 3 and 4. Then you had to go and do number 5. So 5 was on the other side near your data table. You had to color in your electromagnetic spectrum. So just to kind of show what that one, how you're going to use that now, okay? You hopefully colored in your colors, right? And once you have it colored in, you're now going to use what you found yesterday and match up your colors to the different numbers, okay? And if yours is a little off or anything like that, just you know where it goes, right? All right, so for example, with our barium, okay, we had a yellowish goldish color, okay? So you filled in all of this yesterday. You filled in a bunch of colors. I told you to be very specific. Don't worry about the last row. We'll do that Monday, okay? But you filled in colors all the way down. Today, if you didn't do it yesterday, you need to match those colors up to these values that are across right here. Feel free to do in-between colors. So like, for example, on that one, we did 630 because it was a little more on the yellow side, a little beyond it, okay? You could have gone the other way. So a lot of people in the last period did more like 575. That's fine as well, okay? So it's kind of up to you and your group what you're going to put as. You're quantifying those colors, okay? Okay, so you should have had your color spectrum colored in. All right. So that leads us to what you're accomplishing today. So down here, you're going to find your approximate wavelength of light using the visible light spectrum. So that's the part that I just showed you. You're matching it up to one of those numbers. That goes into that data table. Okay? So that one is this column. All right. Then number 2 says we're going to convert each wavelength from nanometers to meters. Okay? So, when we go to convert the wavelength from nanometers to meters, what you're going to be doing is you're going to go divide by 1E9. Okay? You're going to divide by 1E9. You're going to fill out this whole column with that. Okay? So for example, back to our, so I think I gave you guys strontium yesterday, right? So I said it was like a pink red. So I went ahead and gave it the number of 675. Okay? So if I put 675 there, I'm going to take 675 and I'm going to divide it. So in the calculator, I'm going to push divide and I'm going to go 1E9. So if you're using my calculators, that's what you're plugging in. We kind of practiced it a couple times. If you're using Google Calculator, in order to get this E, you're just going to hit the EXP button. Okay? So if you're going to use Google, that's what you would use. Okay? So you're just going to convert all of them into your wavelength in meters. Okay? So pretty simple. That's all you're doing. I am making number 3 and 4 bonus. Okay? So these are bonus. I don't mind showing you how to do it though. So basically when I did that, I typed it into my calculator. I got 6.75 E negative 7. That's what the calculator told me back. Once I have that number, I can now calculate my frequency. Okay? So frequency is going to be your speed of light divided by wavelength. So it's going to be 3E8, and then I'm going to push divide, and then I'm going to type in whatever I got for the wavelength. So mine is going to be 6.75 E negative 7. Okay? So I'm going to make, like I said, these two columns right here, these are optional. Okay? Your bonus. Bonus question, or bonus. All right. So when I type that in, I end up getting, I believe it's 4.44 E14. Okay? That is my frequency. Once I have that frequency, I now can plug it into the other equation, which is just multiplying it by 6.63 E negative 34. You're just doing this equation that's right here, okay? So I'm multiplying it by Planck's constant. And then you can get your energy there. Okay? All right, so those are bonus. We're all clear? Bonus? Awesome. But you do have to get your wavelengths converted. So number 2 is not optional. You do have to do that. So 1 and 2 you have to do. All right, so once you get to that part, now the rest of it is just post-lab kind of questions. So number 5. Oh, we're going to do that Monday. Don't worry about doing that. You're still going to turn it in, but we're going to add it on Monday. Number 6 says, why should that and have the same color? So talk with your group and figure out what your answer is. That's perfectly fine. Number 7, how does it relate to where they're located on the periodic table? Feel free to try that one out. So 6 and 7 are just post-lab questions. Okay, so you're just doing 1, 2, 6, 7. Then on the other side, up here, okay, I want you guys to cross out your high frequency, low frequency things, because you should be able to relate wavelength to energy. What did we say they are? Directly or indirect? Indirect. So as wavelength goes up, energy goes down. They are indirectly related. So what that tells you is that your longest wavelength will have the lowest energy. Your shortest wavelength will have the highest energy. Okay, so you should be able to fill those two things out. It'll be a repeat answer, just so you know. And then this, you'll be fine. Go ahead and just knock those out. All right, quick answers. And then as soon as you're done with that, you just turn it in. So that is kind of what I'm expecting of you today. And then you should be able to take your pictures and get it submitted on Schoology. If not, you can email